This lecture is a follow-up lecture of the recursion tutorial video 1 in which we learned about the basic concept of recursion and did one program. So in this lecture I am going to solve 3 programs so that we can get a better hold of what recursion really is. So I am gonna go and solve 3 problems and the first one is I have to print from 1 to n integer using recursion. Let's dive into it. Let's do some formalities. Now let's take print as a function and I'm gonna pass 2 arguments. First is int n and the second is int I. Int n is the target and int I will be the iterator and it will be printed as you'll see. So let's say if I becomes greater than n, then it should return, as we don't want to print numbers greater than I. Now out I, and what we'll do is the n will remain same, but now what we'll do is we'll say I plus 1, as we want the value of I to increase at every iteration, at every callback, so that it can print itself. Now writing main function n, and we have to initialize the I variable so that it can work. If we don't, then it won't. It will show error. And now we just simply have to write n comma I, and I think this should do it. Let's try and run the program. Let's take a number 5. So it works, as you can. It works from 0 to 5. If we want the program to not print 0, then we can just go here and edit it to 1, and I think this should do the job. Right? Yeah, it does. So this one is solved. Now we will learn to do the opposite, and I think it is quite easy, as you can understand. You would have made a guess by now. Again write a function, and this is easier than the previous program, as we need only one variable, and so we have to print n to 1. So if I becomes greater than n, then we should return the function, as we don't want values greater than if I equals to 0, then it should return, as we don't want value, as we want the I to stop. Right now, just this should do it. This one is quite easy, and just take input of I and now pass the function. the main program. That's it. I think they should do it. Let's try to run the program, and let's say 5. So yeah, it works. 5 4 3 2 1. It does work. So this one is also done. Now we have to come to the last program. As in this program we will calculate the factorial of any given number using recursion. So the formula for factorial is n into n minus 1, right? So we'll use it. As let's create a function known as factorial, and I'll pass only one argument. So the factorial of 0 and 1 are 1, so we have to pass, so we have to check this condition too. So what we'll do is, if n equals to 0 and, so this is the symbol of and, sorry, or symbol, it is a logical symbol, then this should return 1. And since we are writing return, so what we'll do is we will change this from void to int, as int does not take any returns. Now what we'll do is else return n into factorial n minus 1. So what we'll do is, it is multiplying by itself, by calling itself, but with a little modification in its argument value. I think this should do it too. Alright, let's see. Factorial of 5, 120. Yeah, it worked. So we learned about recursion in previous video, and today we practiced that 3 problems so that we can understand recursion better. As in all the 3 programs, the function is calling itself again and again to calculate its value, but with a little modification, as we can modify the arguments. So what it's doing is, it is again calling the program and again applying the logic, but with a little change in the value. So this is what recursion does, right? And there aren't any values, and this is done so that time complexity can be reduced, as we are not using any loops. You know, all these problems can be done using loops, nested loops, but it will take a lot of time, which increases time complexity and makes programs slow. So this is why recursion is used, so that we can decrease time complexity and make programs way faster than it will be using loops. Thank you for watching.